To integrate an Android app with a RESTful web service, you'll need to make calls over the network. You can choose from a few different HTTP clients, some that are included with the Android SDK, and some open source libraries that are available from various organizations. The Android SDK includes two HTTP clients, the Apache HTTP client and an implementation of Java's HTTP URL connection class. Both follow existing API models, so if you're accustomed to using these models in other Java environments, you'll find these instantly familiar. But as with everything in the Android SDK, the implementations are specific to Android. The Apache HTTP client consists of two main classes, Default HTTP Client and Android HTTP Client. These are both extensible Java classes. The Apache API is powerful and flexible, but it's also very large and complex. It handles most common HTTP scenarios and all HTTP request methods. But since about 2011, the Android team has not worked on improving this API for Android. So whatever features or bugs it had a few years ago are still there and will remain for the foreseeable future. Here's an example of using Apache HTTP. You start off by creating an instance of the class you want to use. In this case, I'm using Android HTTP Client, and you construct it by passing in a string, which is the user agent, a string that identifies the client to the server. Then you define your request. If you want to do a simple GET request, you use a class called HTTP GET. And then you pass in the URL, the location of the service you want to call. You execute the request and get back a response. And then you can process the response. This code would process a simple string. The Apache HTTP client offers lots of benefits. It requires really minimal code for simple processing, and it's highly stable with very few known bugs. However, as I mentioned, it's not currently being worked on. As far as is known, this aspect of the Android SDK has been frozen. Whatever it does today is what it'll do tomorrow and for the future. The Android development team's focus has been on HTTP URL connection, the API that's defined in the Java libraries and is implemented in the Android SDK. HTTP URL connection is a member of the package java.net. When you use HTTP URL connection, you'll also use the URL class. And then to process the requests and responses, you'll use other classes from the package java.io. HTTP URL connection is a much more lightweight client, and it's perfectly suited for use with web services. The Android implementation of this class has been continuously improved with each new iteration of the Android SDK, and the Android development team sees this API as the best choice for all new apps. And so that's the HTTP client that I'll use primarily throughout this course. Here's an example of using HTTP URL connection. You start by creating a URL object, and then you use that object to create the connection. All the rest of this code is getting the content from the server and processing it. And this is classic boilerplate code for retrieving a string-based response from the web. You'll see when we get into the demonstrations that there's more code than this because you have to handle a bunch of error conditions. But this code is the core of how you make a simple request and get back a simple response. In addition to basic HTTP features, such as the ability to make requests with all standard methods such as GET, POST, PUT, and DELETE, the Android implementation supports response compression and caching, two features that can significantly improve app performance and reduce network usage. But because it's a low-level library, using it can require more code than the Apache HTTP client or some of the open source libraries that I'll show you. And that brings us to these open source libraries. There are a number of these, and they have different capabilities and different pros and cons. The first one I'll describe is called OKHTTP. It's a free open source library from Square. OKHTTP is essentially a replacement for HTTP URL connection. It mimics that API, so it's easy to plug it in instead of HTTP URL connection, but retain most of the rest of your code. And it adds or improves on some critical features. These include connection pooling, transparent handling of gzip formats to shrink download sizes, and response caching. I'll give you a complete demo of OKHTTP in this course, and you can find out about it at this URL. I'll also talk about Google's Volley library, which was introduced in 2013. Volley is a library that offers comprehensive handling of HTTP downloads. It supports parallel simultaneous requests, something that's harder to do on your own, and it uses the JSON library, a library available from Google, to decode JSON formatted content. It handles device configuration changes such as orientation changes automatically, something you'd have to code yourself if you're using the lower level libraries. Some of the challenges in using Volley include that the documentation is very slender and there aren't many official examples. There is no strict versioning of this library either. Essentially, to use Volley, you go get the source code and you plug it into your application or compile it into a jar file yourself. But Volley does a great job handling both string and image-based responses when you're working with web services. You can find the Volley library at this webpage. And finally, I'll talk about RETROFIT, another comprehensive library that manages RESTful services from top to bottom through a coding model known as interface abstraction. With interface abstraction, you create an interface and define your web services using annotations and abstract methods. This is an example of defining an interface for retrieving data from GitHub. Once you've defined the interface, it takes just a few lines of code to make the call over the web and retrieve content. RETROFIT goes even further than Volley. It doesn't just know how to get JSON-based content, it actually can decode the JSON content and transform it into strongly typed objects, something that's incredibly valuable when you're working in the Java programming language. RETROFIT offers interfaces for custom data converters and lots of other great features. As with Volley, the documentation for RETROFIT doesn't really feel complete, but it's in better condition than Volley, and there are plenty of samples out there on the web. You can get the RETROFIT library from this web page. And again, I'll give you a demonstration of using it in an Android app during this course. So that's a look at all the different choices that are available for making HTTP requests over the web. I'll start the course talking about the built-in libraries, including the Android HTTP client and HTTP URL connection, but I'll also show you the higher-level open-source libraries that can reduce your code and make your apps run faster and better.